If you did part 1 from your homework yesterday where we found zeros and multiplicities and maybe some in behavior, then today should be a fairly easy transition for you. Let me get this full screen here. One other little shortcut that we have is looking at turning points and looking at the degree. Okay. Now a turning point is simply a max or a min, or wherever this graph changes from increasing to decreasing or decreasing to increasing. So as you can see, this graph has 4 turning points right here, one at each one of these little hills and valleys. And what it says is that that's the definition of a turning point. It says if I have a polynomial of degree n, if I look at this polynomial, I'm so sorry it's so small, but that polynomial is degree 5. It says it will have at most n minus 1 turning points, which makes sense. I had 1, 2, 3, 4 of them. So I subtract 1 from that. I had 4 turning points. And so that's just another way to help check your graph. Okay. If you want to, go ahead and find how many turning points we should have on these two, and then you can come back and hit play. Make sure you're looking for that highest degree, and I did a little bit of multiplying on this part B right here to get the highest exponent. But anything else I multiply out on this would not give me an exponent as high as 5. So I'm feeling pretty confident with my 4 turning points on that. Okay. I want to show you 2 different ways that we're going to graph. Okay. A lot of the homework problems that I'm looking at for this year, they're in the factored form. So I'm wanting to work with it in this factored form for now. So the first thing I'm going to do is I'm going to find my zeros, x equals 0 and x equals negative 3. This first way I want to show you is just solely if you can find the zeros. Maybe you're not understanding all these other little shortcuts I'm showing you along the way. Well, you can just plug in 0 and you can plug in negative 3 right here and know that those are x-intercepts. Okay. And so now what I'm going to do is I'm going to make myself an XY table. Now I'm going to get kind of specific here as to what I plug into my XY table. Okay. I have 3 neighborhoods happening right here. I have neighborhood 1, neighborhood 2, and neighborhood 3. And I want to make sure I'm plugging in an x value from each neighborhood. Now, the behavior of this problem, this thing is going to go absolutely berserk once we get into neighborhood 1 and 3. The values are going to get big. So whenever I choose a value from neighborhood 1, I'm going to choose something that is very close to the point, to this negative 4. So I'm going to plug negative 4 back in for these x's. So I get negative 4 squared times negative 4 plus 3 squared. So that gives me 16 times negative 1 squared, which is just 16. Now my graph doesn't go to 16. Like I said, these things are going to go berserk. I'll just call this 16 up here, whatever that top number is, and you can do the same. So now I'm going to plug something in the second neighborhood. So far today, both my classes have said negative 1, so I guess that looks a little bit more appealing. So I'm going to go back and do all this again, but I'm going to plug in negative 1 in for x this time. So negative 1 squared, that's just 1. And then negative 1 plus 3 is 2. Squared is 4. So 1 times 4 is just 4. So negative 1, 1, 2, 3, 4, right? Now, if these numbers are getting in your way, I apologize. I'm just trying to show you the neighborhoods. So I'm going neighborhood 3 now. And again, I'm going to pick something very close to the 0 that's in that third neighborhood, the number 1. So I'll come up here, plug in 1 again. Well, I think give me 1 squared, well, that's 1. And then 1 plus 3 is 4. Squared is 16. 1 times 16. So 1, 16. This is an extra little point right here. I don't know if I can get, there we go. And I just connect the points left to right. I'm going to get full points for that graph. Okay. I'm not really interested in the y-intercept of this. It is 0. I guess I was interested in it since it was 0. But if it's anything other than 0, I'm interested in x-intercepts. And I like to check my work with what we did yesterday with the multiplicities. Both of these have a multiplicity of 2. And if you remember what we talked about yesterday, if a 0 has a multiplicity of 2, it's simply going to touch the x-axis, or we called it bouncing off the axis. And that's exactly what it does at both of these zeros. At negative 3 right here, it comes down and it bounces off the axis. At 0, it comes down and it bounces off the axis. Also notice my end behavior on this. All right, I have positive coefficients in front of both of these zeros. So I'm looking at positive, and if I add up my degrees right here, I add up the 2 and the 2, or simply come down here and add my multiplicities, I got a 4th degree polynomial, which is even degree. So if I look on my note card for even and positive that we made yesterday, what happens is I see that I should get a graph that goes up to the right and up to the left. And so it does match everything I've drawn, and I feel much more confident about my graph. The other way I want to show you the graph is using the shortcuts to graph and then just using that as my final answer. It's a little bit quicker, okay? But we've got to know all the shortcuts if we're going to use this. So first off, I'm going to list my zeros to where I touch the x-axis, and I'm going to go ahead and throw the multiplicity under each one. This is multiplicity 3, multiplicity, I'm not sure if I have put 2 t's in there. This is 2, and MULT. There we go, multiplicity of 2. So I'm going to start with this, go through and label all these. So 0, 1, 2, 3, 4, and negative 2. And then next what I'm going to do is I'm going to look at my end behavior. Ooh, I got a negative that slid on this one. So I have a negative 1, a positive 1, and a positive 1. So a negative and a positive is going to give me a negative leading coefficient. And again, I can just add up my degrees, 1, 2, 3, 4, 5, 6, 7, or add my powers, and I get a 7th degree polynomial, which is odd. So I want to look at my note card, and I want to find odd and negative, or negative and odd. And on my note card, that's the one that looks something like this, where it went up to the left and down to the right. And so this second way I want to show you is I can, instead of making a table, I can just simply look at that note card, make it of some use to me, and make it so it goes down to the right and up to the left. Next, I would just go left to right and use my multiplicities. Okay, I am not very interested in any of the y values on this. I'm interested in whether they're positive or whether or not they're negative. And so if I look at negative 2 right here, negative 2 has a even multiplicity. If you remember, if I have an even multiplicity, I'm supposed to come down and bounce and stay on the same side. Looking at 0, 0 has an odd multiplicity. So if the multiplicity is odd, I'm supposed to cross the x-axis. And finally 4. It should match up with what I already have for my end behavior. But the multiplicity is even right there. It comes up, bounces off the x-axis, and stays on the same side. Like I said, I'm not interested in what y value these go to. I'm interested in you plotting your zeros, giving me a hill or valley between each one, and then your end behavior. I'll be more interested in those values whenever you take calculus with me and we can find exactly what some of these important values need to be. Let's try these in reverse. I love working problems forwards and backwards. So working this in reverse, I still want to find my x-intercept first. Okay, look and see where the graph's crossing the x-axis, set up some factors that involve those zeros. Next, it says examine the behavior of the graph at the x-intercepts. I don't think I'm going to give you anything that snakes just yet, so I'm just interested in whether something bounces or crosses the x-axis, and then putting the correct multiplicity on that 0. All right. From there, I'm just wanting to use any other point, and I'm just going to try to make the problems look like what we have seen so far today. So I'm not interested in foiling out anything to get a long polynomial. Rather, just leave everything in this nice factored form. So, but we do need to check and see if there's a stretch factor, just as we have done in the past week when we were working with these. So they give me a graph. This is a very similar question to what we had on the quiz earlier, where except for instead of just me listing the zeros, you get to go find them. And so looking at this, I see that there's a 0 at negative 3. So I'm going to put x minus a negative 3. Actually, I'm going to put x plus 3. And there's another 0 at 2. So x minus a positive 2 will just be x minus 2. And the same thing with 5. Okay, so I found my zeros. Now I need to state their multiplicities. At -3, I am crossing that x-axis. If I cross the x-axis, that means I need to have an odd multiplicity. And the nicest odd number I can think of would be 1. So it's just going to be to the first power. At 2, I'm touching though. Remember, if I touch, I need an even multiplicity. I'm going to use 2 for my even multiplicity. And at 5, I'm crossing again. So I use the nicest odd number I can think of. Like I said, if it snakes right there, it does a little bit different, but I'm going to try to make them so they're straightforward, either touch or cross, not do anything any fancier than that. I have to find my stretch factor though. So usually there's going to be one other point they gave me that's super nice. Ooh, look at this 0, -2 right here. Okay. A lot of times it's on the x-axis, this other point that they give you. So what you're going to do is you're going to go through and plug in 0 in for all these x's. And you're going to plug in a -2 in for this y. You're going to find out if this thing's been reflected, if it's been vertically stretched or vertically compressed. Okay, so the -2 is going to hang out here. All right, so I get a 3, a 4, and a -5. Oh man, -60 it looks like. I hope that's right. -60, divide both sides by -60. Man, this thing's been very much so squished down from what it has been. 1/30. So my final answer, and you can put the ones in there or not. I'm going to go back and erase this and just plug that A back into this top right here, would be 1/30 times all this. Good luck. Have a great rest of the day. Let me know if you have any questions.